In this video, I'm going to be talking about how to solve a radical equation. So up until this point, hopefully you know how to solve regular equations. What I mean by that, like 1-, 2-step equations, maybe some equations with some fractions or parentheses or something in them. If not, I'm going to put a link in the description box below if you need to go review some of the initial steps of solving an equation. The main important step, though, that I would want to make sure that you knew and that you did review is whenever we are solving a basic equation and we're trying to solve for variable and get it by itself, excuse me, the main focus is to get the variable by itself, so we want to get rid of everything else. And when we do that, we do the opposite of what we have. So for example, if I was solving this simple equation here, if I want to get x by itself, I do the opposite of a -3, and I add 3 to both sides, dropping down the x, giving me a 13 here. So when we're solving a radical equation, we need to understand that the opposite of a square root of something is squaring it. So raising it to the second power. A square root and a square are opposites of each other and they cancel out. Same thing, if I had an equation where I had a square term, the opposite would be to do a square root of it. So they're opposites of each other, and we use that in solving an equation. So as long as we understand that one main concept and our basic solving equation rules, that makes these problems here a lot easier to solve. So we're going to go through the following 3 examples. Starting with example A, first when we approach a radical equation here, we do want to first make sure that our radical is completely by itself on one side of the equal sign. So you can see with this example here, there's not anything really hanging around this equation other than the square root. For a non-example, maybe take a look at example C over here, where I have a 2 plus the square root of 3x. So this square root is not by itself because it has this 2 over here. In our example here, the radical is by itself, so that's good. That's what we want. We can go straight to solving. The first thing we need to do is get rid of the radical. So remember what I said, the opposite of a square root is a square. So I'm going to square the left side of this equation here, which also, the second most important rule in solving an equation, what you do to one side, you do to the other side. So if I'm going to square the left side, I have to square the right-hand side. On the left-hand side, remember the square root and a square cancel with each other. They are opposites. So I can drop down that x minus 2 that we have underneath. And that's going to equal to 3 squared. So that is 3 times 3, which gives us a 9. This brings us down to a one-step problem here. I have this x minus 2. We need to get rid of the minus 2, so we will plus that 2 on both sides. Negative 2 plus 2 cancels, leaving us with x, and 9 plus 2 gives us an 11 over here. So that's our solution for this particular equation. Moving on to example B. So if we look at example B here, I do see that we have a square root on either side of the equal sign, which is fine. We're still going to approach this the same way. Our square root is by itself, so that's okay. We can go straight to solving. Excuse me. So the opposite of a square root is a square. So I'm going to square not only the left-hand side, but I'm going to also square the right-hand side here, because remember, what you do to one side, you must do to the other side. The square root and the square is going to cancel out on both sides, so just drop down what you have underneath. So 4p minus 2 on the left, 3p plus 5 on the right. Continuing to solve this equation here, I'm going to get my variables together. So this 3p is a positive 3p. I'm going to subtract that 3p on both sides to get my variables together here on the left. 4p minus 3p gives us 1p. Drop down that minus 2. We haven't done anything with it yet. That's going to equal to, we had a 3p, but we subtracted it away, so it's gone. That zero's out. We still have that 5 hanging out, though, so we can drop that down. So we have p on the left-hand side here. In order to get that by itself, all we got to do is get rid of this minus 2. So we do the opposite and add 2 to both sides, making it cancel on the left, and on the right we get 5 plus 2, which gives us a 7. Moving on to example C. So this example here, my square root is not by itself. I have this 2 hanging out over here. We need to get rid of that first before we do anything else here. It's a positive 2, so I am going to subtract it away. 2 minus 2 goes away, so I can drop down the square root of 3x is equal to 7 minus 2 gives us a 5. So I have my radical on the left-hand side completely by itself, so the opposite of a square root is a square. So I'm going to square both sides, so hopefully you're seeing the similarities in these problems here. So again, make sure you do remember square root and square are opposites of each other. Getting rid of that square root and that square leaves us with the 3x is equal to 5 squared. 5 times 5 is 25. In order to solve for x here, we need to get rid of the 3. Remember that this is 3 times x, so the opposite of multiplication is division. Dividing that out on both sides, 3 over 3 cancels and gives you an x is equal to 25 thirds. This does not divide out evenly. 25 and 3 do not have anything in common, so we cannot simplify the fraction. That just means that our answer is 25 over 3. Otherwise, that's it for this video.